Hello, everybody. So today is probably an exciting day. 8 people on the roster in this course. 5 are software developers are in the software development program. So over half are software developers just have to take this course. So today we're going to get into SQL, actually writing our code to control the databases. Is that we haven't been doing that since day one because that's the part I know really, really well. Oh, I'll let her in. Hey Corey, we were just started a couple seconds before you came in. I was just announcing today we're getting started into SQL a little more like the actual coverage of SQL, not just the periodic using it like we've been doing since day one of the course. Cover that in detail. Couple other things before we get started with that. There's going to be another group work day. I did decide to do that next Thursday. The next assignment for the group is due in module 8, but that's the last week of the semester, so I assume everybody's really busy that week. Right? That's always a hectic, exhausting week. So we'll do that next week, which is week 7, Thursday, and that way you have a little bit of time to clean up after. But that'll be our next required on-campus class day is Thursday, May 4th. And I'll send out announcements reminding you about it and things like that. At least one, probably 2 announcements since that's still a week and a half away. So there you go, don't miss that. From where I was sitting, it looked like the group work went a lot better, went really well. And when everybody was in the same place the other day, there was a lot of progress made. I've gotten used to online group work, and projects and classes seem to move very, very slow. So it was nice to see everybody in the same room. One other announcement. So last week was the discussion board where y'all were supposed to use ChatGPT and then evaluate its performance, how well it wrote those things up for you and stuff. And I'm gonna start doing that in every class because that's a tool. It's not going away. Personally, I consider it's the next update on a keyboard. We started with typing one symbol at a time, then it moved to like predictive text, then swipe text on touch screens, typing a full word at a time, and those things like chatbots. They write it like a keyboard that writes a whole sentence at a time. Is what I consider them. I don't like to use the standard abbreviation because there is no intelligence in there. It doesn't know what those sentences mean. All chatbots know how to do is recognize a really good sentence. They'll generate lots and lots of sentences and pick the best looking one. That's why you always want to remember not to trust them. But I'm going to do that in all the courses, but it's kind of important here because data analytics work is what goes into making a chatbot. It's probably 99% of the work of making the chatbot is data analytics work, cleaning up the data set. You do lots and lots and lots of time cleaning up your data set, getting it in the right form so that your AI model can process it. And then you write maybe a dozen lines of code. 12 to maybe 1 or 2 dozen lines of code on a really big one. So there's not, I did say dozen, not hundred. There's not even very much in the programming aspect of it. We're not inventing it. We're just using it. And by far, most of the work is working with the database, cleaning it up, organizing it into the form it needs to go into that. So things like that, chatbots and machine learning, AI in general, is data analytics work. Now that it's been invented, obviously it was a different group that invented it, but the biggest part of the task is getting your data set ready. So things like we're looking at in this class. Okay, so that was the announcements I had, and I guess, the big thing for today is getting started into actual going through SQL and looking at some of that. Had something ready or have something ready as normal. And actually I have two things ready. So we're gonna do it today. And what we're gonna do today skips over what sort of the previous work, last week's work. Because last week, I guess the week before was all the stuff about normalization, right? Right before that, we did this, one of our class examples was done really quick before we got to normalization. And when I thought about it, I decided I wanted to, since we're gonna do 2 days of covering SQL, I wanted to do 1 day, go back to this example on the first day. I cleaned it up since our in-class example. As I was getting ready, I made some changes, but it's not a normalized database. So we'll look at this. So that way we can actually see the problems if we don't get to at least third form in a database. It's usually, there's the productivity loss if we take it further than third form. And that's a human productivity loss, so we can't even predict it. The decrease in human productivity is going to be very different on a Wednesday morning versus Friday afternoon. On Friday afternoon, the database administrator is getting exhausted, ready for the weekend. So the performance is going to drop even further. And then we have all those other things dealing with that there. But if we don't get to at least third normal form, we can't guarantee all of our functionalities there. But as you all have hopefully noticed by now, what just flows out of most people, especially in our modern world where we're used to filling out forms to go into a database or seeing our data spit back out from a relational database. We're used to them, so what just naturally flows out of most people is almost always in at least second normal form. So it's just a little bit of work to get to third. But then those others, ECNF, and then after that you get 4NF, 5NF, ETNF, DKNF. 6NF is theoretical. Nobody's going to take it that far. 6NF is where you have a primary key in one column and lots of tables. So it's really like a one or two column table, and nobody takes it that far because that's just too excessive, too machine oriented for humans. So that's the theoretical one that nobody's ever going to go to. The domain key normal form is the top one. So I did clean this up, and let me share this with you all in the chat here. Share. Copy the link. Oh, I'll just download it, actually. Actually, yeah, I'll go ahead and I was going to do something else. So there is the share link. I don't think you all have edit access if you use that link. Somebody check that real quick. It's in the chat room. You're not in the chat room, are you, Joseph? I'll email it to you.
So should I log into Zoom?
Oh, I'm sending it out right now in a way you have access to, since you all can see it on the screen. Can somebody log in there and tell me if you have edit access? As soon as this goes out.
Is it on Zoom or?
Oh, I was sending out as an announcement, but it's in.
Oh,
Uh,
that was me. That was.
okay. Yes, link from class. Because I also want you all to make a copy of this because, well, I'm pretty sure I've stated it explicitly before. normalization is one of the most important things that we'll get out of this class. So we want to make sure we're very familiar with that. I can't get to the, oh, there we go. Zoom pictures were anywhere, no matter where I went. So if you go to that link, you should have view access to it, because I was also going to make an assignment. We're going to go through this today as an example of what goes wrong if we don't have that. Oh, let me change that. Now does it go in? Okay, sorry, forgot to, I forgot to actually give you access with the link. But we're looking at the unnormalized forms, so we can see what can go wrong with it and where we hit problems. In particular, when things go according to the plan I put together, when we get to the end, you'll notice that the diagram we generate from our database is not going to match this diagram, because it's not really in normal form. Can anybody look at the picture now and tell me which form it would be in? Go through in order, there's an obvious clue on there. It'll be more obvious in a moment. But I want to make sure you can spot those things. Things that'll jump off the page sheet. So you'll notice some things on here I changed it a little bit. So I have emails, a bunch of integer IDs, foreign keys, primary keys, connections, and I set up and included arrays here, which over half the class is software developers. So as software developers, that's the one we think of first. We're working with an array in our program, so we think about that here. So there's that link. Is it still in the, Charles just came in, so I'll paste that in the chat room. There's a link to the diagram we're going to use today, Charles. It's an update from one we did in one of our in-class examples a couple weeks ago from before normalization. And we're going to look at the unnormalized form today just to get started into SQL and see what goes wrong if we don't go to at least third normal form. The reason we're spending so much time talking about that and all of those assignments. So we can actually see it. And I'm going to add an assignment that you'll take a copy of this and update that to normal form, and then we'll use somebody's normal form. I have one in mind too, but on Thursday there'll be an assignment due on Thursday of just adjusting this to what it would take to be normal form, or at least write out the bulleted list of the steps would need to take to get it to third normal form, so all of our functionality will work. I'm gonna leave that open. Everybody should be able to view it and kind of see what's going on with it. And well, obviously, part of that is also to refer to while we put this together. And another point, just in case you hadn't realized it, right? It's hard to notice every little point along the way. The person that makes the diagrams is going to get paid more than the person that does the typing. Right? The project manager does the project, or oftentimes it gets the label architect. The database architect is the one that draws the picture and normally gets paid a lot more than the person that looks at that picture and types it up in SQL code. But as far as in a classroom, especially, it's a lot more fun to type SQL code, right? So we should jump into that part. The class is over half software developers, so that's probably the part y'all are anxious for. So you can open a text editor. You'll need some sort of text editor to follow along. The normal places we write our code. Hopefully that's big enough on the screen. Everybody will be able to see it. So SQL is we'll write some words on the board covering the general introduction to the language and stuff like that. Want to make sure we get all our terminology down. while y'all get your text editors open. So looking at SQL today. SQL is an imperative just wrote the wrong word. That's not a good sign. Start off with the wrong word. It's not, it's the opposite of imperative. It's a declarative language. Declarative. If you don't remember those from or haven't encountered them before, an imperative language is where we tell the computer how to do something. That's where we write all our loops and selection structures. And like, if this condition is true, then print these words over and over again until the condition's false. And how to carry things out. And opposing that is declarative language, where all the things that it's going to need to do are already built in. You can think of it as functions for those who've done a little bit of programming. Think of it as all the functions are already there. We're just going to ask for the functions in a different order every time, or slightly customized order. I have an error message implant in mind here in a little while, but when we look at error messages to see some things, but we have a bunch of keywords. Keywords. It's an interpreted language. And that counters being a compiled language. So in a compiled language, we take an entire file, all of the instructions we write, we turn those into machine language, and then we have a file size instruction for the machine, and then run it all at once. In imperative language, we go through our file one line at a time. So we have all those lines in the text file. We'll like grab line 1, turn that into machine language. And then I'm just making up some bits there. We have something the machine knows, machine or assembly language or bytecode. There's a number of steps along the way, but something that the machine actually knows what it means, not the human readable text, because the machine doesn't know anything about text. But we'll turn it into that, and then we'll run that one instruction. Then we come back over here, grab the second instruction, and repeat that process, one line at a time. So if there's an error on line 5, lines 1, 2, 3, and 4 are going to run, and then it crashes on line 5. Versus a compiled language, if there's an error on line 5, it's not going to compile to begin with. So a declarative, interpreted language, that means we have a bunch of keywords to work with, and when we put our instructions together, they're going to run one line at a time, and every line is kind of independent of the others. So order matters. That's one big thing. With a compiled language, we can get around the order matters some, because if the instructions are in that compiled file somewhere, the computer can find it. But if we're starting at line 1 and finishing line 1 before we get to line 2, the computer can't look ahead at the instructions and find something else. So we have to pay close attention to order. Order always matters. Sometimes we can get around that in compiled languages. And since it's not as common as it once was, since everybody starts with Python these days, we do have the end of instruction character. End of instruction. Nowadays, most people start their programming experience with Python, so they're used to just a line break at the end. A semicolon is, well, when we put it in our text file and think about it, we're going to think end of instruction. There's a little technicality. Technically, the semicolon means next instruction, but I got some Python code, or some code like you've probably seen.
if we store value in X and then say X equals X plus 1, this code works, right? Everybody wrote something like that before? Well, the fact that this line works tells us with certainty that the machine reads our instructions right to left, not left to right. So when it's reading our instructions, it hits the semicolon at the end of the line first. So technically, that means next instruction. But because it goes at the end of the line when the way we type it, it's going to be a lot more, it's a lot more useful for us to think end of instruction, not next instruction when we think semicolon. So we do have to put the semicolons in there. That's the big parts of the language, declarative and interpretive. We have a bunch of keywords and they're often in human readable form or semi-human readable form. It matches the English language. Other people in the world, SQL can get a little tricky because it doesn't necessarily match their language. Like Japanese. If you've never heard direct, well, actually everybody has. If you translate Japanese directly, that's how Yoda speaks. The verbs and direct objects are reversed. In other languages like that, SQL seems a little out of order to them. But it was made by Americans, so it follows the English language naturally, or a lot of the European languages. They're all based off Latin. But it goes in that order, so the keywords kind of fit in something that almost seems like a human readable form. So there's a few we're going to look at. We want to So what I want to get to today is we have keywords like create. We're going to make something. Then we need some details about what we're going to make. Lots of things we can create. An insert. In particular, we're going to insert into something. There's different ways those keywords can be mixed in different orders. But on day one, especially, we're only going to insert into a table name. I'm just going to write dot, dot, dot on the board. We'll see it in examples now. We can select, so we want to choose things. So make our tables, put data in them, select a bunch of stuff from something. We'll get at least that far today, maybe update and alter. And like I said, we're going to look at this this one that is not normalized to see what can go wrong when we normalize it. And then after class, I'm going to send out an assignment to that'll be due by Thursday to tell me how to normalize this database. And then we'll do the full normalized version so that all of our relational database functionality will work. And when I say fully normalized, I mean third normal form. Is beyond third is where we start to lose the benefits of it because human productivity drop. And but like I pointed out earlier, the thing that flows naturally out of most people is usually second normal form. It's usually even improved from just the bare minimum to be second normal form, and it's almost in third to begin with. So typically there's not much effort to get into third normal form so all our functionality works. I actually had to come around and put effort into making it completely not normalized in this example. And to see what some of those things are talking about, working some better examples about normalization. But first thing we need to do is create, well, we have to create something to work with. So we need to create a database. We're going to create something and we want to create a database. And we zoom out just a little. Yes.
So So would we save this to that other website?
I'm not sure what you mean.
I think it was like during one of the first assignments.
Right now, we're just gonna be writing the X files. We're just writing the code.
Oh, I
So-
thought it was.
The instructions will be in the assignment. I haven't wrote it yet.
Right. I didn't get that much sleep last night.
I'm sorry. So starting off, we want to create a database and then we have to give it a name. So there's always going to be something like that. So our SQL keywords fit together to form a pattern. We're going to make something, in this case, make a database. And then we have to follow it up with what it's going to be called. So create database. This is that lawn care example. If you remember that, one of our first examples, I think it was week 3, maybe week 2. So I'm just going to call this database lawn care. Then end of instruction. And go save this somewhere. Documents, leave. Oh, apparently. The purple one was still in there, so I'll just give it that way, and then that way I get the color changing to spot keywords. But it was mentioned earlier, unlike some of the other things you'll see in classes related to programming, SQL is not a single language. SQL is a category of languages. So there's lots of different flavors of SQL. So you do need to know which one you're working in. And those databases we set up where we're actually gonna go run this code in a moment is under MariaDB, which is one of the 2 flavors of MySQL that came out in the 90s. The first big update on what Oracle released in the late 1970s. And what WordPress and Wix and Squarespace use, really WordPress is because of WordPress, they're so common for making websites and content management systems that whatever WordPress does, anybody that wants to be a domain host better be set up for WordPress. So anytime you go to a free domain host or pay for a domain hosting site, you can count on MariaDB being there. We're using it in class because I had to get ready in a couple days. This is the one that shows up all over the place, especially for software developers. So I know I can answer questions about MariaDB all day long off the top of my head. Oracle stuff, I'd have to go look up a few things except for the stuff that's exactly the same as it would be in MariaDB. So we're going to create a database. But then it is still programming. After we create it, we need to say use database. Which database to use. So we created lawn care. So now we want to make sure and tell the computer explicitly to use lawn care. If you're on one of the hosting sites where they created the database for you and you just go in there and make tables, you can skip that line. We'll add comments in a little while. We'll look at comments in a little while, maybe comment that line out, keep for reference. That actually creates the database on the domain hosting sites where you're restricted. Like the typical one will give you 3 databases to work with. So you don't actually create the database, you ask them to create the database and then you just fill it up with tables. So if you're using that, like the online version, you want to make sure and skip those first 2 lines. But as always, it's a good idea to test every chance you get. You don't want to wait till the end when you have lots and lots of code written to go in and run a test. So I'm going to go ahead and open up the PHP MyAdmin and just run those first couple lines, see what they do. And show the first error in a moment. But there's not an intentional error in the code yet. We'll get those in a second. So I'm doing that really quick. So when we log into PHP MyAdmin, whichever one you're using, you'll notice about halfway across or so, you should see an import button or an import tab, I'm sorry. Go to import. We choose that file we just made. Or started, it's definitely not made yet. And then there's a whole bunch of options on things that we can load customize. The default should be good, and down at the bottom is a button to actually import that file. And hopefully you see a whole bunch of green when you do that. So there's nothing in it. We can see over here, we at least now have our database where we can start creating tables and working with the stuff there. We could go do it one line at a time. It's an interpreted language. So every line is independent of all the other lines. If you want to, you can come right here and type this stuff one line at a time. But there's usually a lot of things we want to put in there, and little mistakes can happen along the way, typos and things like that, right? So it's a lot better to save it as a big file when there's lots of stuff to do in the database. And let me upload that again. Come over here and upload that again. Get an error message. This is one of the nicer error messages we'll get from MySQL, because it clearly says what the problem was. That database already exists. So there's a couple options. In general today, what I'm going to do is come back to the top level. If you're doing this on your local machine, you can come back to the top level and do it. If you're on the domain host and they created the database for you, then that line's not going to be a problem. I'll show you how to fix it, but and select, hit the checkbox there. Remember not to delete any of the things that came with MySQL, because it depends on databases itself. So hit the checkbox for the one that you want to get rid of, and the drop button will get rid of it. Drop that database, and then we can import another one. A better way to fix that, and something you're going to want to do a lot, especially in the text file, is a couple other keywords we have. Anytime you use create, if it's going in the text file, adding in the words "if not exists" are a really, really good idea. Because now we can avoid that obvious error that we can't create the same database twice. So check to see whether it exists or not. And that's kind of what this week's going to be. We're going to look at a whole bunch of keywords to get started. The ones we use most often. But the SQL class specifically, DBMS 130, where the entire course is just the programming language SQL, and you do a lot more interesting things. When we get to the big intentional error, I was planning on throwing in a little while. I have some points about that you'll see. It goes a lot further than what we're going to see in 2 days of a classroom, obviously. So now we have that's the better way to fix that. Anytime you use create, if you're in a text file, you probably want to do that. Either that or delete. Make sure you drop your database every time so you don't get changes. Now we need to put something in it, right? And yeah, a couple of these we've seen since day one. We're going to create something. And in particular, we want to create a table. And our general form, we kind of saw earlier, looks like create thing. Then we give it a name and follow it up with details. There's a good little thing to put in your notes for what a create query looks like. There are multiple ways we can make comments. I'm going to use what's normally a multi-line comment. Actually, what happens if I just ask the text editor to do that? In most text editors, if you have a line and you hit Control/, Control forward slash will comment things out. Okay, it wants to comment things out that way. We can also use 2 dashes. But there's the general structure of the create statement. So we want to create something. What are we going to call it? And then what details do we need in order to create it? So creating a database, call it lawn care, and then the if not exist kind of goes in there. I think of that as part of the create statement. The conditions under which to create it. So I'm going to add that everywhere. So if not exist, that way we don't actually do it twice. So create the table, and we look back at our picture over here on draw.io. I guess employee table is a good place to start. So we need an employee table with an integer for an ID, a name, a salary, and the skill sets that that particular employee has. And you can see the data types I chose when I set it up. Name's obviously character. Salary is going to be in money, and I put 5 digits because I was thinking like a daily salary. If you remember this example, it was lawn care work. So what does each person get paid per day? Maybe you think of it like day laborers instead of the hourly rate or something. And then skill set, most people on the crew are going to be able to use more than one piece of equipment or something. So create table if it doesn't exist, and we want the employee table. And then in parentheses, we'll add in all the details about the employee table, which can be done in one line. You can do it in one long line. It gets to be a mess if we do it that way. So most people kind of prefer to split that up and put all the other stuff in here. We have that semicolon. So we explicitly tell the computer where the instruction ends as far as the text file is concerned. So it's clearly marked. So white space doesn't completely matter here. You do have to have a space between your keywords, or really a space between everything. Things are space delimited. But other than as a delimiter, all space is ignored. So you could just as well have tabs between them. You'd have 10 spaces between your keywords. You'd have 10 spaces and line break and 5 line breaks and a whole bunch of random spaces on every one of those line breaks between the keywords. As long as it happens before the semicolon, it'll be good to go. Oops. So things like indentation are only for human readability. You're the one putting this file together. You're the one that's got to come back and edit the file. So you probably want it to be nice and readable so you can keep things straight. So what was in our table? What was it not previewing? I was gonna try it. Oh, Zoom's preventing that just like pop-up preview. That would be very useful here. So employee ID, name, salary, and skill set. So we have employee ID, which is an integer. And kind of important, right? We talked about all the normalization stuff. We really only need to worry about third normal form. The rest of the stuff is that rare situation where you really have to worry about every single little detail and you decide that it's worth the extra work. But even up to third normal form, we need those primary keys. So our primary key better not be empty. That's kind of an important one. Name sounds like text. I'll just do it all in one line, say 64 characters. They're up to 64 characters for their name. And then we comma separate each one of our fields. So we get the field name, which is also, you may have noticed in books and other reference material by this point, is also often called a field key. That will be very important when we get to next week and talk about non-relational databases, non-relational stuff. Because primary keys aren't our only keys. We have that word shows up a lot. A primary key is just the most important key. I'll say maybe the name can be blank as long as we have the employee ID number. and keep track of them. Salary is a number, but in particular it's money. And since we're going into a MySQL, one of the flavors of MySQL will use the word decimal, but if we were on Oracle, we would need to put the word number there. So there are slight differences. And I was thinking like day wages, so 5 digits, 2 of them after the decimal place. And skill set. And this next thing I'm getting ready to write is because over half the class is software developers. So we're most often going to make databases that go align to a particular piece of software. And that particular piece of software is going to have, we're going to have lots of arrays and lists and things like that, right? So I wanted to show you how to put an array right in your database. Because several of y'all did notice it when in the assignment about types, the JSON array is a type. We'll look at what's wrong with that being full on being a type of data in here in just a second. But we need a place to put it, and we're going to put the JSON type. Oh, I already typed it. But JSON type does not go in as JSON type. Because JSON is a text file, right? That's the problem with using JSON for our entire database is it's a big, huge text file. It's just a big, long string of text. So we have to read that entire string of text in order to parse things out of it. But when we need to store that JSON type, it goes into just a really big text field. For our purposes, 512 characters is probably enough to store a bunch of an array of strings. Sometimes it might get bigger. Sometimes we might need to get up to those things like big text, maybe even blobs, depending on how big your array is. But when you set up your data type, it's not JSON type. I might as well mention it. The reason that's there is actually for the select statement. When we get our data back from the tables, it's really nice to put it into an array. But there's a problem when we put it here. One more keyword that we always want to include is we have a primary key. We want to say what our primary key is. So primary key is going to be that employee ID field. I missed a comment. I had an extra line break in there to separate it out. But that's the proper way to set the primary key. There's a short syntax. There's long and short syntax. So we're going to be looking at the long syntax here because the short syntax, like every shortcut, there's a trade-off for taking the shortcut, right? Think about where shortcuts show up in like movies and books and stuff. Whenever the main characters take a shortcut, that shortcut is going to cause the conflict for the plot of the movie or whatever. And a similar thing can happen when we do the shortcut version of typing the SQL code. There's a trade-off for it, so you have to be careful with it. So in class this week, we're going to be looking at the formal way of doing it. So after we set up all our fields, we say, okay, we have a primary key, and then in parentheses, you can say which primary key it is. Does all that make sense? Does it seem kind of readable? It's not the most human readable name. I see head nods in the classroom here. Hopefully some on Zoom call as well. It's not perfectly straight English, but it was made by Americans, so it should make sense. Since I'm going to talk about that JSON data, I'll go ahead and jump ahead to an insert query, and then we'll run a test. So once we get our table made, we need to insert some data into it. So keywords again, so insert into, and the equivalent of if not exist for an insert into is a bit complicated, so we'll just go ahead and insert duplicates without worry for our class examples. Because we're just starting out in SQL. It might be one of the things if we have time on Thursday, but it gets a lot more complicated to choose whether or not to insert the data. So insert into, and then we need what table are we putting stuff in? And at this point, this is a good point to talk about capitalization. So I did that. So for SQL keywords, it is not case sensitive. Either uppercase, lowercase, camel case, Pascal case, whatever. However you want to adjust your capital and lowercase letters is fine for the SQL keywords themselves. Those are built into the language. For any of the things we name, any of our reference values, like employee, the name of this table here, this one would not work because it is case sensitive. Which can be a problem too, because depending on where you're working at it, if you're doing it in a terminal, MySQL and Oracle will spit everything back out in lowercase. So even though we wrote that table name with a capital E, every time MySQL prints it out, it's going to print it with a lowercase e. But if we try to ask for something about it with the lowercase e there at the beginning, it'll throw an error because we created it with a capital E. So you do have to watch out for that. Then we want to say what we're putting in, what fields to go into, and then the values that we want to put in. Almost never put a space there. So that's the generic version of that. I'll add that in the notes here. So for our insert queries, we have insert into table name. And then in parentheses, the fields we want to insert things into. And the values, I guess then the actual values we're putting in there. That keyword works very nicely there. And then comment that line out. Did it all fit on screen? Or close the little side section. Sidebar. Yeah, that pretty much fits on there. So there's the general structure of it. Insert into a table. What fields do we want to insert into? And then the values that we want to insert into. And the fields can be omitted if we're inserting into every single field. In the order that we created them. If you want to insert them in a different order, or if you're not going to insert that in every field, you have to explicitly list that. But we can omit that part right there if we know if we're filling in every single field. So I'll do that here. So I'll leave the parentheses off this one. And then we'll just enter the values that we want to put in. Which again can be a bit of a mess. So, well, actually, I'll leave that off of one here in a moment, and then we'll split it. We'll do that in a moment. But you can see, as one line, that one's going to be a bit of a mess. So a lot of people like to split it up a little and add in some indenting and white space just to make it easier to read. Because I guess edit would be the big thing. Right? If we make a typo, we have to come back in here and edit this. So we want to be ready for that. So I'm just gonna, let's see, insert into employee. We have ID, name, salary, and skill set. So we want to insert it. Employee ID, a name, this person's salary, which what I had in mind, I probably should have called it the day wage or something. It's only goes up to $1,000, I guess. Only goes up to $999.99. It's in good for example. So we want to insert in, well, it's every field in this case, but these fields in this order. And then the values we want to put in. And we do have to watch type. So employee ID was an integer. So we'll insert an integer. I guess this is employee number 1. Name was Sally. Our salary, $123.45. Sounds like a good not awful wage for a couple hours work. I guess that is only like $12 an hour, isn't it? $13 an hour. It's typed in now. It's good for the example. I would probably complain if somebody paid me $100, only paid me $100 for a full day of cutting grass and doing a bunch of lawn care work, but it works for our example. And then the skill set, we need what skill sets are going to be in there, which kind of have to jump ahead a little bit for this one because we haven't gotten the skill sets in our database yet. But I was thinking things like grass and tree. I have to come back and make some corrections here. Grass and tree, and oh, that probably would be good. But what I wrote on there is a problem, right? Because our different fields are comma separated. But just do it that way, it looks like there's 5 pieces of data going into 4 fields. So we type JSON array. What was spelled out? It's generally bad form, so I had to look this up. I had to look this up when getting ready. JSON array, and then wrap that in parentheses. That's that JSON data type that a number of y'all mentioned in that assignment a few weeks ago. And it wasn't actually made for a data type in our table. Let's go look at why. Everybody following along, get that copy down. So come over here. Database has been deleted, so I'll come over here and upload that file and run it. And well, at least on this one we're using, you can see it's nicely color coded green. We saw one error already. You get a great big red box if it's an error, a bunch of little green boxes if it worked. And important for software developers, when you're having your program do this, look at the return. Look at what we got back. So we got back the time it took. And it returned a 0. All those so return 0, so that's create the database, use the database, create the table, and then this time we got back a 1. So the return, very important for software developers that are required to take this class. What you get back is the number of rows inserted, and 0 is valid because we can do stuff without changing any rows. Our first 3 instructions all return to 0, and that's accurate. But if something goes wrong, then you get back a negative number. So if you get, right, we can't affect -3 rows. So if you get back anything smaller than 0, that's how you know there was an error message. And also the time that it took to run those things. Now we come over here and look at this table. Created all that. We got our primary keys. We have the buttons. And earlier when we looked at the picture, as from looking at the picture, can you tell what normal form it is? And nobody really said anything. But now that we have our first table made and some data in there, can you tell now which normalization form we're in? Because remember, unnormalized is a form as well. What's our criteria for first normal form? Somebody want to spit out some of the criteria? Nobody remember? So I keep bringing it back up. Does compound data sound familiar? We can't have any compound data. That's the problem with using JSON as a data type. Is we can't even get to first normal form if we use the JSON. We use the JSON right here. I could have been here because the programmers are gonna want to do this and you're probably gonna want to do this. And so if we have a small database that's growing with one piece of software, that'll be fine. So I want to show you that. But there are 2 data points in that one field. So really that data type only exists for our select statements, not our insert statements. When we get, because we could have that spread out in lots of fields and then turn them into an array, turn them into a JSON array afterwards. But as you can see, it doesn't throw an error, but here we have compound data type. And another thing I wanted to point out is the typical examples you'll see, like YouTube videos and things, they always try to use very simplified examples, and it's almost always name and address that they use for compound examples of compound data. But that point's debatable. We all have a first and last name, middle names. Some people have several names, right? They go together. You don't separate. Your first name is not enough to uniquely identify you, nor is your last name. Everybody in your family has the same surname. A lot of people have very common names. Looking at the list of who's here today, some of y'all are probably like me. If I'm walking around, say, a mall, and hear somebody yell, "Hey, Chris," I'm not even going to turn and look, because it would be a very rare occurrence that I walked through the mall and didn't hear somebody yell, "Hey, Chris," but they weren't talking to me. Just a common name. So whether our name is compound data or not is kind of debatable. Same thing with address. You need the whole address. You can't really split it up. At least like the street address. The numbers without the street don't mean anything, and the street without the numbers don't mean anything. So are those really different points of data? So I wanted to make it, at least one example that showed very clearly what is meant by compound data. And the JSON data type is compound data. So if you use that, which doesn't throw an error, but that it's in the language for a different purpose. We don't want to store it that way. We want to retrieve it that way. After we pull it out of storage, we throw it in an array and then send it back to the software. That's the proper form for using that one. Lots of people mentioned it, and I didn't take off any points or really say anything at the time because it's not wrong. That column is set up to store JSON array, the JSON data, but we couldn't just go type that in like it was one of our things. It has a different purpose, and it prevents the first normal form. So that was one of the first things I wanted to show. And on Thursday, we're going to normalize this. And we're actually at a point where we can do something like this. So if I go over to the SQL tab, we can preview the last query that we haven't seen. Now we'll look at different ways we can combine these things. So maybe we want to select the salary from, we only have one thing, from the employee table where employee ID equals 1. Kind of a trivial selection, but that's the one we haven't seen yet. That's going to show up at the end of the day. But we've seen all the other keywords. We've seen most of the other keywords that we're going to use now, and might as well preview this before taking a break. And there's a button that says go. We can click that. Control Enter. Whenever you have little inputs like that, is the standard. It's standard that they set the shortcut to Control Enter to run that. Whereas Enter just adds a line break. You can see we get back just that one data point we asked for, so the whole thing. And that's the biggest advantage of the relational databases again. Remember that our full table, that was over and storage, and eventually the full database, that's over in storage, that's on hard drive. But we do all our work in RAM, and we don't want to bring everything that's on the hard drive over to the RAM chip for whatever task we're doing. We want to be able to filter it over on the hard drive. And that's where relational databases really show up. We filter it between the hard drive, and then this is this one number, and the key that goes with it is the only thing that shows up in RAM. So we're not filling up our RAM chip to access our data. Back up here. But that's a much better example of what's meant by compound data. So we're not even in first normal form yet. We'll redo this normalized on Thursday. But there were a couple errors and things I wanted to put in and show what could go wrong. So I decided we just look at the syntax for SQL first and see this and go, and since 5 out of 8 people in the class are software development majors, show you how to put an array into your database. Because I think all 5 of you mentioned the JSON data type, but it's not really a data type. It just doesn't throw an error. There's a slight difference there, right? But it works. Got more to go over. Gonna get quicker and quicker. For those who haven't had through code examples, they get quicker as we go. I usually start slow and it'll get faster and faster, but now's probably a good time for a break. 10 minutes sound good to everybody? See how Nod's here, see how permission here. So my laptop says 2:03. We'll get back to it at 2:13.